problemas de internet. María Sofía, no te angusties, mi niña, tranquila, Sofi. No hay problema. Si tienes problemas de internet, no te preocupes. All right, guys. All right. Today, we're going to take a look at what are exponential equations. Now, in the past, every time we saw a new type of function, we also solve the equation for that function. So we saw linear functions. We had linear equations. We saw quadratic functions. Well, we know how to solve quadratic equations, right? Polynomial functions, so polynomial equations, and so on. So it makes sense that now that we're talking about exponential functions, well, we talk about what are the equations in here. Here's a quick example how to solve one. Example, solve the following equation. 4 to the 3x, right, equals 4 to the 2x plus 5. Now, some people might be looking at this, and these people might be saying, what am I what do I have to do? What is this? No, this isn't Chinese. I don't understand. All right, don't worry. I got you. Don't worry. Look at this. Here in the board, I have a couple of examples on what is to solve an equation. I'm going to write it down for you guys. Hopefully, you guys are writing down this as well. All right, what is this? To solve the equation. Whenever the exercise or the quiz or whatever we're doing say, solve the equation. What is the teacher expecting you to do? Pretty simple. You need to find the value of the variable. Find the value of the variable. Now, I'm saying of the variable and I am not saying x because sometimes the variable changes. In the first example I have here, the variable is x. In other words, the letters that we have in an equation kind of look like variables. The second equation has, you could be thinking, all right, we have the x twice, right? We have the x here and we also have the x here, right? So you might be thinking, this has two variables. No, that's a mistake. We only have one variable because in reality, we only have one x. Sure, it appears twice, sure, but it's just x. If we had something like this, 3xy, 3xy equals 7 or something like that, I don't know, I'm just creating this from the top of my mind here. Then we could say that we have two variables because in this we have two letters. Different letters represent different variables, right? If we have the same variable, if we have the same letter, then we have the same variable. So to solve the equation, that is to find the value of the variable. In this case, we're going to find the value of x, and in this case, we are also going to find the value of x. All right. How do we do this? Pretty simple. Here we have the equation. What we have here is a number that we don't know, a number that when we multiply by 3, and to that result we add 2, the result will be 14. So you can kind of guess values until you get it. For example, you can say, I don't know, what if the value of x equals, I don't know, 2? Could it be x equals 2? Can the answer be 2? Remember, we are solving the equation, so we're finding the value of the variable. At the end, we need to find the value for x. So we can think that x could be 2. How can we make sure of that? Well, we simply replace. We simply replace. We simply replace the value in the equation. So here we have 2. We have 3 times our value of 2 plus 2. All right, how much is that? This thing is 6, right? 6 plus 2. This thing is 8. Well, it is not 14, right? It's not 14. So the result is not 2. Can anybody please tell me in the chat, what is the result for x in here? What is the value that when I multiply by 3 and add it to 2 gives me 14? All right, thank you guys. A lot of people are writing in the chat. Thank you guys, appreciate it, thank you. All right, beautiful. The answer, guys, is 4. We know that x equals 4. Again, how can we make sure of that? We can simply replace the value and see for ourselves. Replace. All we have to do is replace the value and we can see for ourselves if this is right or not. So we have 3 times 4, which is the value we are replacing. Double color. Plus 2. All right, how much is this? 3 times 4, that is 12 plus 2. Look at that. It was 14. It was 14. So we have a good answer. X is, in fact, 4. That is the idea behind solving the equation. Just finding the value of 4. That's it. Just find the value of 4. That's it. Now, some equations are easier than others. That's a fact. In mathematics, some things are easier than other things, right? And in this case, some of you may have done this like I did by guessing. You could have, I don't know, take out your calculator and start giving values for x. So you can say, I don't know, x equals 1 and do the multiplications and the additions. And the result is not 14. So you change the value of 1 for 2. And it doesn't work either. For 3. Now, for 4. Oh, look at that. For 4 works. That is a good process. You change the values with the help of, I don't know, your calculator, for example. And at the end, you tell if it is a good result or not. That is a good process. The problem with that process is that it takes a lot of time. You need to write down a lot of values. That is a problem, right? I mean, if the question was just this, then you can do it however you want. But let's say you have this times 10. You have 10 of these questions in a quiz, and you can only spend 10 minutes for that quiz. Well, guessing the values in the calculator is going to take a lot more time than 10 minutes, unless you are extremely lucky, which I don't think so, right? Could be, but I don't think so. So what I'm trying to say here is guessing is not really a good option. We need to find a process, some way in which we can find the value of x without having to guess. And that process is called isolation. Ooh. All right, let me raise this in here. What I'm about to show you guys, I am expecting 100% of you to know it. But I know some of you may forgot some things here and there, so I'm just going to show it anywhere. How do you isolate a variable? Here. Isolate. Isolating the variable means moving everything else that is not the variable, moving it to the other side. And to move it to the other side, we have some characteristics, some rules. We can only move them in certain order, and we can only move them if we change them with the opposite operation. So here, the main, what we are going to move first is the +2, and since we need to move it with the opposite operation, we're going to do this +2. We're going to mix it into a -2. So what we are left with is 3x, and in this other side, we have 14 minus 2. Did you see what I did there? I am isolating the variable. So everything else that is not x, I'll move it to the other side. I am working in steps. So this is the first step. Of course, I want to get rid of this 3 as well. But I need to get rid of the 2 first. The 2 is adding, so I'm going to move it as negative to subtract. In here, the 3, I'm going to move now the 3. All right, since the 3 is multiplicating, right? What we have here is 3 times x. Both the 3 and the x are multiplicating. And the operation opposite to multiplication is division. So that is why to move the 3, sorry, we're going to divide everything by 3. Did you see what I did there? This is called isolation. This is what we usually do. Now, all we have to do is do this little operation in here. Look, 14 minus 2, that's 12. 12 divided by 3, that's 4. So what we have is the value of x equals 4. Again, I am expecting 100% of you to remember how to isolate a variable in this simple equation, right? Cool. That's a good process. Can we apply the same process to any other equation? Yes, we can. Yes, we can. Now, there are some other tricks that we can apply to different equations when they are harder. For example, equation number 2. Number 2. In here, we have a quadratic equation. How do we know? Because the x is elevated to the 2. So that is a quadratic equation. Again, to solve the equation means we need to find the value of the variable. So without doing any process, we can start thinking about what number do I put in here so that when elevated to the second power, gives me the same as if I just added 2. Again, we can just guess values. So we can say, I don't know, how about x equals 3, for example? I don't know. We can say that. All right, let's see. So if I do that, I'll have 3 to the second power equals 3 plus 2. Did you see? The 3 is the same value that I'm saying for x. So I'll replace them in the 2 positions for x. Now, all I have to do is do the mathematics in here. I have 9, and in the other side, I have...
Teacher, I get a little bit lost. From where do we get that 3?
Danny, thank you. Danny, we are guessing. So we're just saying a value that we think could be an answer. I decided to say 3, but you can say, I don't know, 7, 12, 1, whatever value that you want, negative something. Guessing means give a random value. And that is what I did. I just gave a random value. Better?
Yeah, thank you, teacher.
All right, thank you, Danny. All right. And look at these guys. By this random value, 3, the equation is not good. 9 is not the same as 5. We should be getting the same on one side than the other one. So 3 is not a good guess. And we can spend a lot of time here guessing values until we get it. For example, what if we say x equals 2? Is this a good answer or not? We can check. We can replace to see if this is a good answer or not. All right. So we have 2 to the second power equal 2 plus 2. All right, let's see. 2 to the second power, this thing is 4 equals, oh, look at that, 4. So this is a good answer. 4 equals 4. Look at that. X, in fact, is 2. Again, just by guessing, put in random values for x and replace them. That is a good process. And in here, I was lucky. I was a lucky guy because in the second attempt, I got a good answer. Question is this the only solution? Or can I have another value? The only way in which I can solve that for sure is with a process, by isolating. And that is what we can do. In here, since we have a quadratic equation, we can use the quadratic formula. Do you guys remember about that? Let me write it here, the quadratic formula. X is going to be equal to minus b plus or minus the square root of b squared minus 4ac, and all of that over 2a, right? We can use this little formula. And look at this. In this formula, the x is already alone. So the x is isolated already. This formula is so good, so powerful, that it let us not have to do the process of isolation. All we can do is just replace the values and we are done, right? So if we do that, of course, we're going to have to reorganize this equation. We have x squared minus x minus 2 equals 0. Look at that. I just moved it to the left, right? And in here, I can apply the formula. Now, I did this already. I know that the answers are -1 and 2. These are going to be the two answers. Because if I replace these two values in the main equation here, I am going to have an equality. Look at that. -1 to the 2 is 1. And in here, -1 plus 2 is 1. 1 equals 1. That's a second answer. Look at that. So what I'm trying to say, guys, here is that you can spend a lot of time guessing the values to be able to solve the equation. You can do that. Spend a lot of time. And eventually you will get the answer. But it is easier when you have a process. Isolation is called the process. With that, let's jump into the exponential equation. Ooh. All right. Here. How can we solve this? Solve the following equation. How can we solve this? Guys, Does any one of you have an idea on what is the value of x? All right. I'm not saying do any process because maybe you don't know any process in here, right? Maybe you do. Maybe you study this. I don't know. But if you don't know how to solve this, it is okay. What you can do is change values of x randomly until the equation makes sense. Anybody has an idea? Nope. Nobody. Okay. I'm going to show you how to solve this. So here, solve the following equation. What we have here is that when the bases are the same, we can set the exponent equal to each other. So what I mean here is, look, in the first example, we have 4 to the 3x, right? That is an exponent, right? I don't know if you guys remember about this or not, but this little 4 here is called the base, right? In any exponent like this, a to the b, I don't know, any number elevated to another number, the big number here is called the base, right? And look at that. In our equation, we have two exponents, one to the left of the equal and one to the right of the equal, right? We have two powers. And both powers have the same base. This is 4 to the something, and this is 4 to the something as well. So when that happens, we can simply cancel the exponents. You heard it right. We can just simply cancel the bases, sorry. So we can say cancel the 4 and cancel the 4. Like that. And what we are left with is the exponents. So look at that. 3x, that was the exponent of the first equation, equal 2x plus 5. 2x plus 5. The exponent of the second power, right? Again, what I just did was to cancel the bases. But I can only do that if the bases are the same. If this is a 4 and this is another value different than a 4, then I cannot cancel the bases. That is the process. All right, so look at this now. This equation that was an exponential equation, something that we didn't know how to solve, is now a linear equation, one of the easiest, right? So you guys remember how to solve this or not? Nope. All right, to solve this, simply move the x's to one side of the equation and leave everything else to the other side. So here we have 3x plus 2x, right? So we're going to move the 2x up to the other side. This is going to be negative 2x. 3x minus 2x. Did you see? 3x, the positive 2, I move it as a negative. And this is equal to 5. From here, all I have to do now is solve the operations here with the x's. So we have 3x minus 2x. That is 1x alone. And look at that. We just found the value. That's it. We just found the solution. That is it. The solution of the main equation, this one, the horrible one here, the exponential equation, is 5. And you can check that with your calculators yourself. This is 3 times 5, right? So this is 4 elevated to the 15, right? If I replace 5 by x, 4 elevated to the 15. That is a huge value, a huge value. But it's the same value here. Look at that. 2 times x, but x is 5, right? So 2 times 10, 2 times 5 equals 10, right? 2 times 5. And 10 plus 5 is 15. So what we have here is 4 elevated to the 15. It's the same value. Now, I don't know how much is that value. But to the left, we had 4 to the 15. And to the right, we have 4 to the 15. So we have perfectly solved the equation. How about that, huh? How about that? At the beginning, I am sure some of you look at this and you said, man, I have no idea how to do this. And now you know. And I think it's extremely simple. All right. I think we can go with a second example. How about this? Solve the following equation. a to the 4x equals 2 to the 6x minus 2. So guys, let me know in the chat, please. I want everybody to write down. Everybody. Tell me, can we cancel the bases here? Yes or no? Everybody, write it down. I'm not going to read answers. Don't worry about that. All right. No. Beautiful. Thank you, guys. All right. Beautiful. Okay. I'm not gonna read answers, right? Somebody asked something, but I don't wanna read it. I'm just gonna continue with the explanation, and after I continue with the explanation, I wanna solve the question of that person. All right. Okay. From here, we cannot cancel the bases. Remember, in the previous example, the only reason why we could cancel the 4 and the 4 is because the bases were the same. The bases were the same. So we can only cancel them if the bases are the same. Here we have an 8 and a 2. So we cannot. What can we do then? Look at this. In this problem, the bases are not the same, but we can rewrite one of the expressions to get the same basis. What? Yeah, sure we can. Look, 8 can be expressed as a power from which the base is 2. 2 to the 3 is 8. So what I'm saying here is this. Look at this. This is the main equation, right? Now, the 8 is 2 to the 3. Did you see? 2 to the 3 is 8. And that whole 8, the 2 to the 3, is being elevated to the 4x. So I am not changing the equation. I am not. In case you cannot see this, let me just do a little drawing here. This part, the 8, is this one. So we have 8 to the something, and in here we have 8 to the something as well. I don't know, maybe you didn't know, right? But I'll show you here. 2 to the 3 is 2 times 2 times 2. And that thing is 2 times 2 is 4 times 2 is 8. 2 to the 3 is 8. So what we're doing here is we are rewriting the equation so that one of the exponents have the same base to the other. Because now look, the base here is 2 and the base here is 2 as well. We do have a problem though. We do have a problem. Look. 2 to the 3 to the 4x. That is power of a power. Do you guys remember that property or not? All right, I'm guessing you guys don't. All right, don't worry. I'll show it here. Let me show you this. Whenever we have power, so this is a power, right? A to the n. And this is elevated to a different exponent. The way we solve this is by doing the same base, but the base is going to be elevated to the multiplication of those two exponents, n times m. Here's an example. 3 elevated to the 7, and all of that elevated to the 4. By doing the property power of a power, we have the same base, and the exponents are going to be now the multiplication. So 7 times 4. How much is 7 times 4, guys? Everybody in the chat, please let me know. All right, thank you, guys. Some of you actually write it. Thank you. Beautiful. So the solution is 3 to the 28 because 7 times 4 is 28. So this is exactly what we are doing in here. Exactly what we're doing here. 2 to the 3 times 4x. So what we have here is 2, and then the exponents are going to be multiplied. So 3 times 4x. This is the reason why we don't use x's for multiplication, because we have x in mathematics, right? That is the variable. So I'm just going to use a little dot. 3 times 4x. All right. How much is 3 times 4x? So first, I'm going to leave the same base, and now I'll just multiply. 3 times 4 is 12, and I'll write down the x next to it. 2 elevated to the 12x. There you go. That is exactly what we have here. But we cannot forget about that process, guys. We cannot forget about that process. All right. And now that we have the same basis, now that we have both equations to the left and to the right with the same base, now we can cancel the bases. Look, 2 and 2 are going to get canceled now because they have now the same base. Before, I couldn't do it. The 2 and the 8 were not the same. But now that I rewrite the equation, now I can cancel that. All right. So the new equation is just the exponents alone. 12x equals 6x minus 2. From here, simply isolate the x. Move the x's to the one side of the equation. Do the operations in here. And then isolate. The 6 is multiplying, so I'm going to pass it to divide, right? This is negative 2 over 6, right? Which is the same as negative 1/3. Now, you can leave this as a fraction like that, or you can change it into a decimal. Now, I recommend you leave it as a fraction. All right? I recommend you leave it as a fraction. If you change it into a decimal, you could have mistakes. So let's just leave it as a fraction. Of course, make sure the fraction is in the simplest form. All right? Beautiful. Beautiful, guys. All right, let's move into some other examples in here. Problems. Let's try to solve these ones. Guys, go ahead and work in these, please. Let me know if you have any questions. No, you know what? I think we can do this together. Yeah. I think we can do this together. Let's do number 1 and number 3, the C one. All right. And for this, I'm going to have to use my board. So let me just erase all of these and we can do this together, guys. I want all of us to practice with this. All right. Like that. Beautiful. Beautiful. Give me 1 second. There. That's what I wanted to do. Beautiful. All right. All right. So let's try to solve number 1 and number 3. Number 1 is absolutely simple. We're just doing this to practice, right? So I'm going to rewrite the equation. This is 2 to the x plus 1. So this is A. 2 to the x plus 1. And on the other side, we have 4 to the 2x. All right. First, we want to cancel the bases, but we know 2 and 4 are not the same. So we cannot cancel them. We cannot. But what we can do is rewrite the equation, right? Now, I'm going to take the 4 and change it into a base of 2. Why did I choose the 4? Well, because I know 4 is 2 to the 2. I know 4 equals 2 to the 2, right? So I'm gonna use this. All right. That means whatever is to the left, I'm gonna move it. I'm just gonna leave it without doing anything. And to the right, I know 2 to the 2, right? So this is 2 to the 2 elevated to the 2x. Did you see what I did there? The 4 was 2 to the 2, right? Let me do this change. Maybe you guys can see it clearly this way. 4 is 2 to the 2. Huh? How about now? All right, from here, all I have to do is do the power of a power property. Again, to the left, I am not doing anything at all. And to the right, I have the same base. And now 2 times 2x. Well, that is 4x. So now I have the main equation. Again, I am doing 2 times 2x. 2 times 2x is 4x. For the people who did not see this. All right? What do we do now? Well, now we can, in fact, cancel the exponents. I'm sorry, the bases. And the equation will be only the exponents alone. So x plus 1 in here for x.
Teacher,
From
I
here.
just want to confirm something.
Yes, sir.
In most of the cases when we have to rewrite, we normally rewrite the biggest number, in this case 4, in the last example 8.
Yes, sir.
Mhm.
In most cases. You said it right.
Yes, that's my question. What will be the cases when we have to rewrite and not
Excellent
the
question,
biggest number?
Danny. Excellent question. Let me finish this and we're gonna move into question 3, the C one. Can you see it? That's why I
Yes.
choose that one. Because that one is a good example of rewriting the lowest, not the biggest.
Okay, thank you.
Thanks to you, Danny. Keep it up. Keep on asking, brother. Keep on asking. All right, from here, again, we want to isolate x, right? So I'm just going to move the x's to one side and whatever is not an x to the other side. I figure it's easier this way for x minus x. Did you see? The x here was positive, so I moved it as a negative. In here, I know that 1 equals, for x minus x, well, that is 3x. What do we do now? Well, we need to isolate, right? So we have the 3 as multiplication. I'm gonna pass it to divide. So 1 over 3 equals x. And like this, we have our final answer. 1 over 3, that's it. Of course, again, you can change this into a decimal, but it was gonna give you issues sometimes. So why don't you just leave it like that? All right, that is the solution of the first one. Now, I'm going to leave B, question B, the second one, to you, because that one is the easiest. Well, not the easiest, but one of the easiest, right? Go ahead and give it a try. I'm going to give you what? 3 minutes? I think 3 minutes is enough, right? Go ahead and work on B, and let me know in the chat what you think is the answer. Go ahead and do that, guys.
Teacher, what B says? You got
Here, let me
the
make it bigger.
explanations are a
How about
little
that?
bit small. Yes, thank you.
Don't worry, brother. Again, if you have any questions, guys, feel free to ask, all right? The moment any of you get the answer, write it down in the chat. The moment any of you get the answer, just write it in the chat, guys. All right, we have some answers. All right, let's see. X equals 2, x equals 2, x equals 2. Beautiful. All right. Beautiful. Now, I just want to make a quick note about something. I'm not going to solve this entire exercise. I'm not going to solve the entire exercise, all right? I think you guys know it already. I think you guys get the idea. So I'm not going to solve everything. I know. This is what I know. All right, so the exercise is B. I'm not going to solve it everything because I think you get the idea, right? So 3x plus 2 equals 9. And in here we have 9 to the 2x minus 2. All right. So I know 9 is the same as 3 to the 2, right? All we have to do is 3x plus 2. And here I have 3 to the 2 elevated to the 2x minus 2. Here is what I want to show you guys. Some of you may have done this, x plus 2, and then do the multiplication, right? So 3. And in here you do 2 multiplied by 2x minus 2. So some of you may have done this for x minus 2. That, guys, that is a mistake. Let me see if I can change this like that. Better. So that is a mistake, guys. Look. Whenever you multiply, remember, you have to do the distributive property here. This is 2 times 2x, and then 2 times minus 2. So 2 times 2x, that is 4x. That is easier. We have that correct. And then 2 times minus 2, this is negative 4. Right? Don't forget about the distributive property. That is what I wanted to show you in this example. Don't forget about the distributive property. All right? From here, you can just, again, cancel the bases and continue with the process until you get the answer x equals 2. That's it. Congratulations to the people who got this correctly. Beautiful, guys. Keep it up. All right. Let's jump into the question C. That is the one I want to show you guys how to solve. That is the one I am interested in working. This is 2 elevated to the x plus 1 equals to 1/2. What? Elevated to the 2x. What? Look at this. Look at this, guys. Look at this. We have a 2, we have a 1/2. This doesn't look that easy, right? Because in the what I know part, I don't really know what to do here. How am I going to change the 2 into something else? Or how am I going to change the 1/2 into something else? I don't know. I don't know. Well, for this, we do have to remember one of the properties of exponentials. Let me just see the chat in case one of you want to ask something. All right. One of the properties of the exponential. So, did you guys remember what is this property? A elevated to the negative n. How did you guys solve that? What is, or what do we do when we have a negative exponent? Did you guys remember that or not? Okay. We change it into a fraction. On top, we're going to write a 1. And in the denominator, we're going to have to write this same base. Look, this same base. I'm going to do this with an example in a second. And now the same exponent, n and n. But the exponent is now positive. And that is the property we are going to use to change one into the other. We know 1/2 is in this form. A fractionary, look, 1 over something. What I can do is just this, change it back. This is 2 to the negative 1. Did you see what I did? 2 to the negative 1 is the same as 1/2. What that means is the 1/2, I can change it, reorganize it into 2 to the negative 1, which is a value with the same base as this one. Look at that, 2 elevated to something, and here I have 2 elevated to something. So I am, again, rewriting the expression. Only now I'm using a clever property.
Teacher, I already missing something in problem B.
Okay, Danny, tell me.
How will I get that x2? I learned a little bit, how do you say despejar in English?
Isolate.
I a little bit confused with the isolate.
All right.
I already got x plus 2 equal 4x minus 4, and I don't know how to...
X plus 2 equals. So let me try to do it myself. X plus 2 equal 4 x what, Danny? 4x what?
Minus 4.
Minus 4. Beautiful. All right, so you already canceled the exponents, right? That's what you did. You already canceled the exponents.
Yeah, and there is where I'm lost.
Beautiful. Danny, look at this. From here, all you have to do is, from the middle, which is the equal sign, this is the middle, right? We have two parts of the equality. We have the left and we have the right, okay? Now, in one of those, the left or the right, doesn't matter, you choose. You are gonna leave the x's. Here we have one x, and here we have another x. And in the other side, we're gonna leave everything else that is not an x. 2 and 4. All right? Now you should.
I understand.
All right, so I'm gonna leave it as here. I'm gonna leave in here to the right. I'm gonna leave the x's. For example, 4x is already to the right, so I'm not gonna change it. 4x. Did you see? It's already to the right. But this x is to the left. To move it to the right, I'm gonna change it with the negative, with the opposite operation. Here we are adding, so I'm gonna do negative x. Got it? From here, the 2 is already to the right, right? The 2 is already to the right, so I'm gonna leave it there. To the left, sorry, it's already there, right? I'm just making a little bit of a space to write down this number here. And the negative 4, that is a value that I wanna move to the left. Since it is negative, I'm gonna move it as positive, positive 4. Now it's a little bit easier. Again, work from the middle. This part is easier, right? 2 plus 4 is 6. Right? From here.
Yeah, and there is where I am lost. How the hell I'm gonna get 2 is equal x with...
Because of this, simply because of this reason, Danny. Simply because of this reason. You ready? That's a mistake. I think that's a mistake. All right, let's work this out and see if that's a mistake or not. All right, let's work it out. From here, 4x minus x, right? 4x minus x. No. I think it's correct. Look, 4x minus x, right? If we have 4 minus 1, this is 3x, right? 4x's minus just 1x, this is 3x's. Now, again, we are isolating the x. So to move the 3,
now I get it. He divides.
Okay, we divide.
3 divided 6, 2. Yeah,
Beautiful.
Thank you, teacher.
6 divided by 3, so 2 equals x.
Yeah, thank you, teacher. No,
me asustaste por un momento, hermano. Pensé que era un error. Pensé que lo había hecho mal. Pensé que los demás también dije miércoles.
It was just, I was confused with that. I don't know how. Okay, thank you, teacher.
Don't worry, Danny, don't worry. But you get it now, right?
Yeah.
Okay, cool, brother.
Yeah,
cool.
Thank you.
Don't worry, buddy. Don't worry. Guys, look, if you have any questions like this, look, I am now doing question number C. But at any point you have any questions, you need to ask me. Just like Danny's doing, all right? Don't worry about that. Maybe the question is something that I already said half an hour ago. Don't worry. Ask it anyway. I'm gonna help you, all right? I'm gonna help you. All right, we're doing number C. So this was the question, right? 2 elevated x plus 1 equals 1/2 elevated to the 2x. But we know we can change the 1/2 into a 2 elevated to the negative 1. So that is what we're going to do. Again, to the left, I'm not going to do anything. 2x plus 1. And in here, the 1/2, I'm going to change it into a 2 to the negative 1. So I have 2 elevated to the negative 1. Did you see? From here, well, that is 1/2, but the 1/2 is being elevated to 2x. So all I have to do is just that. Write it down. That's it. Now again, this is a negative 1. So from here, we just did the exact same process that we did before. We have power of a power. So we need to multiply the exponents. Look, this is 2 to the x plus 1. Let me do it here. I cannot work in that way, sorry. And in here we have 2, negative 1 times 2x. Well, that is negative 2x. All right. Now we can cancel the exponents, which was the idea all along, right? So what we have left is, we can cancel the bases, sorry. Now we are left with the exponents. X plus 1 equals negative 2x. From here, things are a little bit easier. I'm going to move the x's to this side. So we have 1, negative 2x minus x. The x is positive, so I move it as negative. 1 is going to be equal to negative 3x. And now we are left with a multiplication. Again, look, this 3 has a negative. So you might be thinking, oh, look, the 3 is minus, right? I need to move it as positive. No. The 3 is related to the x with a multiplication. And it is not the 3 alone. Here we don't have a 3. Here we have a negative 3. The value negative 3 is multiplied. So we're going to move the value negative 3 to divide. The solution, 1 over negative 3. That thing is equal to x. This is the final solution. 1 over negative 3.
Teacher, it should be 1 over positive 3?
Yes, Danny. It should not be positive. Why not? Because what is the operation here, Danny? Subtraction?
Multiplication.
No,
it's a
multiplication,
yeah.
right? So we're going to move to divide. But again, we move everything, including the negative.
Okay.
We move everything else, including the negative. Okay? Beautiful. All right, Danny, this is an example. This is an example of when can you change the lower value to get the same base. Here.
Mister, I have a question.
Tefa, tell me.
Is that sometimes in Alex, when you do these kinds of
questions, exercises,
divisions, that is that I don't know if I can put the negative in the center of the more bigger line. I don't know how to explain it.
Fraction.
In the fraction, I don't know if I can put it like.
Yes, you can. All right.
Both numbers are not negative, but I don't know if I can do it. Is that I put it that way, but I don't know if it's wrong.
Okay. Let's make a note here. All right, note. This is something you should know from the beginning, but in case you didn't, well, I'm here to explain it, right? Look, sometimes in mathematics, we mathematicians, we agree on a lot of things, and sometimes we don't agree on some things. This is an example of one of the things that we don't agree. So where did you put the minus? Did you put it down? Did you put it up? Or did you put it in the middle? Here. This is an example. 1 over negative 3. The minus is clearly down, right? This is an example of a fraction that is negative because the minus, well, the fraction has a minus, right? It is right there. You can see it. But in mathematics, sometimes we don't agree where to put the minus. This is exactly the same as saying negative 1 over 3. Did you see what I did? I took the minus down and I move it up. It is exactly the same. You can put it down or you can put it up. It's the same. Just make sure that in the first fraction, there was just one negative. So in the second one, there has to be just one negative as well. If I do this, then things are wrong now. Because all of a sudden, I created a negative. And you cannot do that. But here's the deal. Just like Tefa is saying, again, sometimes in mathematics we don't agree. And we don't have to put it down or up. We can put it right in the middle. Here. This is the same as 1 over 3. No negative, but a negative in the middle. That is correct. Again, the fraction only has one negative. So it is the exact same fraction as this one and the exact same fraction as this one. What I'm trying to say, guys, is that maybe in a quiz, in Alex, for example, you can leave the answer like this. Or you can write it like this with the minus on top, or you can write it like this with the minus right in the middle. Any of the three will be correct. Any of the three. Doesn't really matter which one you choose. Okay? Tefa, that is what you were saying, right?
Yes. I didn't know
Alright.
how to explain it, but yes.
Beautiful. Again, remember, only one negative, only one negative, only one negative, okay? If you do more, then things change. Things change and then we have a mess, right? We have a wrong answer. Just make sure you have just one negative alone. All right, beautiful. That was question C. That was question C. Now, I want you guys to try question E. No, you know what? We don't have time. I'm going to do it. I'm going to do it for you. And then you get to work on the other exercises. These are not the only exercises you're going to do today. We have a lot more. All right, here. Let me erase all of these. And we are going to jump into question E. Because question E is really, really interesting. In question E, you need to mix things. Ugh. All right, E. Let me just write down the question. It is 1/3 elevated to the x plus 2, If the camera focuses, thank you. And then we have equals 9 elevated to the 2x, like that. Minus 2. All right. Take a look at question E, guys. It is right there in the exercises. Sounds interesting. Because now, here, we have 1/3. If this was a 3, then I know this is 3 to the -1 because of what I know, right? I know 1/3 equals 3 elevated to the -1. So I can change this 1/3 as a 3 to the -1. But that helps me in no way. Because the 9 is a 9, not a 3. Can we move the 9 as well? In this example, guys, we have to know two things. The 9 can also be expressed as 3 to the 2. What I'm saying here is that we can do two changes at the same time. That is okay. That is also rewriting the equation. So by changing the first one like this, I have 3 to the -1 elevated to the x plus 2. This is the first part. I am not changing anything. Man, camera focus, please. Here. 1/3, 3 to the -1. This is the first part, right? This is just changing this into a negative exponent. Equal. And now let's change the second part. The 9 is 3 to the 2. So what I have here is 3 to the 2 elevated to the 2x minus 2. Did you see? I had to do two changes in the same equation, one to the left and one to the right. In previous examples, we only changed one, but in here we can change two. We have to. Well, we don't have to. There's another way, but I think this one is the easiest. All right, from here, look, we have 2 powers of a power. So we have to multiply the exponents. Let me show you how. Here we have 3 elevated to the -1, right, times x plus 2. So you have -x minus 2. Again, I am doing the distributive property, right? -1 times x is -x. -1 times 2 is -2. From here, this is equal to 3 times. All right, so we have to multiply the 2 with the 2x and the 2 with the -2. Again, distributive property. So we have the base, which is 3, and 2 times 2x, that is 4x, minus 2 times 2, which is 4. Now we have the same base. Look at that. We rewrite the equation, which means we can cancel the 3's. And now we are left with the exponents alone. So this is negative x minus 2. And over here we have 4x minus 4. All right. X is to the one side and values to the other one. So we have 4x plus x. Look at this. The negative, the x was negative, so I move it as positive. And to the other side, we have negative 2 plus 4, right? The 4 was negative, so I move it as positive. If I want to solve this, on one side I have 5x, and on the other one I have positive 2, right? What is the answer then? Pretty simple. X is going to be 2 over 5. Let me write this equal sign right in the middle so that it looks prettier. There we go. And now this is the final solution. 2 over x, 2 over 5 equals x. Look at that. How beautiful was this one? We had to do two things. We had to know two things. The first one and the second one. We need to do the two changes. Huh? All right. That was a good one, guys. That was a good one. All right, guys. Now it is your turn. Now it is your turn. I'm going to change the slide, and I'm going to show you the exercises that you need to do, all right? Here. Let's work on these exercises, guys. Take out your notebook.
Teacher, you can put your board as again a second, please.
A second, sure, Danny. Here.
Thank you.
Did you just want the board?
Yes, I only need that.
Like that?
Yeah, but still, if the others need to know which page, you can put both.
Okay.
Yeah.
Better?
Yeah.
All right, Danny, go.
Mister, can you put the exercises so I can see where is in the other book?
Right there, Tefa, right there.
No, the exercises, like.
Right there, right? Can
I don't know how to explain. That you search it in your book.
Yeah, those ones. Am I not? What are you guys looking at?
I'm saying.
Can you say it in Spanish? Say it in Spanish. It's fine.
Profe, que pongas la página en donde te aparece a ti para ver en donde me aparece a mí.
Ah, you want me to show you the book? All right. Okay. I'll do it in a minute. All right, don't worry. Let's just wait for Danny to copy this.
Just in time, teacher. I just finished.
Beautiful. All right. Let me open the book then, and I'll show you. Trigonometry. Page 434, right? 434. Exercises 61 to 88. All right. 61 to 88. These are the exercises. All right, cool. Cool, Tefa? All right, guys, now I'm going to leave this in here just so you can solve them, but I'm going to stop the recording here because from now on, it is your turn, all right? Again, if you have any questions, let me know. I'm going to mute the mic to let you work on the exercises, right? But you can work on these by your own. You're not alone. I'm here. You can ask me, all right, guys? I'm going to cut the recording here. And goodbye.